Mingalaba, students. Today we're going to talk about how to simplify, distribute, and combine expressions. Now remember, expressions, they just don't have equal signs. If you put an equal sign, well, all of a sudden you have an equation. So let's get started. The first example we're going to look at is 5x minus x. Obviously, within this, we have the same variable. And remember, anytime you have minus x or plus x, it really means you have one of them. Okay, so writing the number helps. Go ahead and write that number. It may help you with your actual addition or subtraction. So before we move on with this, let's actually come over here and take a look at this example. In this example, we have x equals 8, and I'm telling you x plus x equals what? Well, that's what we want to know. And remember, we have 1x plus 1x equals 2x. And this, when you have a number next to a variable, actually means multiplication. Okay? Now, if we take this 8 and we plug it in for the x, well, 2 times 8 is 16. Perfect. Now, if we just took this 8 and put it right into the x values, well, we get 8 plus 8 is 16. So what you can see is that you get the same answer whether you first combine like terms, okay, and get 2x and then plug in the 8, or you just plug the number right into the variable. Now, that being said, right, we are in a position right here with 5x minus 1x. That's very similar to this. So we have some options. But remember, what we don't know in this case is what x is. So we are trying to simplify by combining these like terms. And once we know our x, then we can put our number into the x value. All right, let's keep going then. So we have 5x minus 1x. Really, all we're doing here now is we are just doing the subtraction. 5 minus 1 is 4, and we have our variable left over. The very important part of this, you can only combine like terms. Like terms mean a variable with the same exponent. Remember, this x, we can fill in a couple things that we don't usually write down. First of all, that it's 1x. And the second thing is it's x to the first power. That is very, very, very important. Even though we don't write them, they're really there. So I could actually write in first power for both of these. And that shows it's exactly the same thing. Okay, let's take a look at the second problem. We have fractions, but it's still the same idea. 1/2 times a, or 1/2 a, plus 3/4 a, or 3/4 times a. Now, is the variable the same? Absolutely. If you look over here, we have AA and XX. It's exactly the same thing. And so we can add these fractions together. Now, we need common denominators. Right now, our denominators are different, so we're just going to change these. So we want a 4. So 2 times 2 is 4. 1 times 2 is, of course, 2. We have our variable. And now that we have common denominators, we can simply add the numbers. So 2/4 plus 3/4 is 5/4. And we have A. Very, very important. Okay? You are only adding variables that are exactly the same. All right, moving on. Now we're going to get into distribution. And if we look at this, we have a whole number times something in parentheses, r plus 3. Remember, can we simplify what's in the parentheses? We always want to do that first. And the answer is no, not in this case. So what we can do from here is our distribution. 3 times both of these. And when we do that, we get 3r plus 9. Oops. In this case, we have to ask ourselves, we have a variable and a number. Can we add terms that are not the same or unlike each other? And the answer is no. Anytime you have a variable, you cannot add that to a number. So we are done right at this point. Now, if we move down to the next problem, we have the same thing to start, but I've added this, 5r to the second power. So before we solve this problem, let's take a look at this example. Over here we have x equals 2. I tell you what x equals, and now I'm asking you to use that with this expression, x plus x to the second power, or x squared. And what I want you to see right away is that these are not the same. We can only add like terms. We can only add things that are the same. So in this case, there's no way to combine these, okay? The common mistake that people make is they'll say x plus x squared. Oh, well, that equals 2x. Or that equals 2x to the second power. Absolutely not. They have to be exactly the same. Okay, if you had x plus y, well then you would not add these together. You would not combine these because they're different. Well, it's exactly the same here. X and x squared are not the same. You cannot combine them, okay? So, taking a look at this problem, if we put the 2 in for the x, we get a 2. If we put the 2 in for x to the second power, well, we end up getting a 4. So what I want you to see here is that these are absolutely not the same number, okay? We cannot just combine them together here. We cannot do that. We have to work through this problem by plugging in the 2 to both the x and plugging in the 2 to the x squared. All right, let's go back over here. Now, we have it written out. We have a variable r, we have a whole number, and we have r squared. Can any of these be combined? The answer is no. We are simplified at this point. Okay? Let's take a look at the next example. Here we have 5 to the second power plus h minus h squared plus 15h. In this case, right, the first thing you always want to do, can you simplify any of these? And the answer is yes. 5 to the second power can be simplified. Do we have a common variable? Well, in this case we do. We have h, and remember, this is really just like 1h, and we have 15h. And then we have our h squared. So we are only going to combine, of course, the common variables. And the h squared is different. We cannot combine that with our h. So I always organize this expression so that the same variable is next to each other, so that you can organize things and hopefully not make any mistakes when you're adding or subtracting. So we have our whole number, 25. 1 plus 15, of course, is 16h minus h to the second power. And now we have everything separated. We have our h's together, we have our h squared by itself, and we have our whole number. Alright, let's take a look at the last one. Now, in this case, we have a lot going on. We have parentheses. Can we do anything with the variables and numbers within the parentheses? The answer is no. We cannot simplify those. So the next thing we'd have to think about is, can we distribute? And the answer is yes. So the first thing we are going to do is distribute. So we have 2y plus 4. And in this case, there's nothing we can do to simplify, so I'm just going to actually write this without the parentheses. Okay? Now, if you notice here below, what it says is I want to write the answer from highest exponent to lowest exponent. So we're going to keep that in our minds. But for right now, what we have to do is we have to say, okay, are there common terms? And we have a y squared. These are not the same thing. We cannot combine them. But what we do have that are common terms are just the whole numbers, the numbers. So we are going to combine them. Now, when I rewrite this, I'm going to rewrite this from highest exponent. Remember, this has an exponent of y to the second. This has an exponent of y to the first. So I'm going to rewrite it like this. Y to the second plus, this is positive, so 2y plus 4 plus 10 is plus 14. And there we go. We are done. Highest exponent to lowest exponent.